Welcome to another VC Physics coaching video. I'm Philip Noonan, and today I'm talking about the A3 summary sheet and sharing some guidelines and strategies. So the A3 summary sheet, that's a sheet you can take into the examination with notes or anything you'd like to write on it. And just in general, it's a great place to add useful reworked formulas so that they're ready to go in a format that allows you to solve questions quickly. They've been rearranged or reformatted. I'll show you what I mean in just a minute by that, although you probably know what I'm referring to. So tick that one off. And common standard definitions, just brief definitions. The main thing is to avoid just writing a lot of information and piling in all that information when you see a question related to it. Which is mainly the last point there. Maybe keep your definitions brief and do make sure you read and understand exactly what the question asks for. It's a bit of a skill, just you can only do the best you can with that. So here's some reworked formulas that I wrote recently relating to light and matter. So it's a lot there, might not be all the ones you've thought of, but it's about 18. So questions involving diffraction patterns, where if the spacing of a diffraction pattern is equal, it means either the momentum or the wavelength of the electrons and the photons are equal. So for example, question might be, an electron has energy of 500 electron volts. What frequency photon would produce the same diffraction pattern? Which means you might go and get the momentum or the wavelength. You can get the wavelength of the electron, or you can get the momentum of the electron, and then assume that the X-ray must have the same momentum or the same wavelength. Either would be fine, but you could use that formula first because you know the energy, and then you could use this one. So the main thing is you wouldn't want to just write all these formulas down and hope you can use them on the day. The more you can practice these in advance and know them well is the better. That just comes with time, which is not always easy, but the more you can do it, the better. So here's some questions, some formulas relating to gravity and orbital motion. So we're equating the formulas for circular motion or circular acceleration and gravitational field strength. And we've reworked them to get three formulas there for the time period of an orbit or the radius of an orbit. So they're sort of ready-made to go. Make sure you use your calculator carefully. Just keep your eyes over the calculator and watch what you're typing in. Sometimes the standard answers, like the International Space Station or any communication satellite with a low orbit of, say, 400 kilometers, its time period's about 90 minutes or so, 92 minutes. So if you get a time period in seconds for those type of satellites and divide it by 60, you could check for yourself that it comes out to roughly that. That's a question that comes up from time to time. Here's some formulas for Unit 4, again, relating to the harmonic series for a string. So you can sort of see the general formula there, and then I've written them out for the first three harmonics. Again, rather than just write these once and say, oh, I'll leave them there now in case I need them, I encourage you to practice rewriting them from scratch. See if you can do them all off the top of your head as a process. Just each time you might have a question on it. Sometimes the examiners ask us to draw a certain harmonic pattern. Right? And remember that for the strings fixed at one end only, that the pattern's a little bit different. It's lambda n equals 4L on n. Okay, not 2L on n as it is for a fixed string. All right, and if you've got time, you can draw those, let you draw those yourself. For special relativity, again, this is Unit 3. Here's another reworked formula for the speed of an object if we know its Lorentz factor. I've just made a bit of a list of common Lorentz factors for various speeds, 90% the speed of light, 99% the speed of light if an object's going that far. Just writing down the fact that the sun converts about 4 million tons of material, of hydrogen, into helium every second. Just seen that question come up once or twice. Here's some notes regarding energy levels. Once again, it's good practice just to draw transitions. Notice how I've been methodical about the way I draw them. Sometimes we're asked to number or count the number of transitions. So rather than do them randomly, It's good to be methodical. There's a bit of a standard definition for why the wave properties of electrons might explain discrete energy levels, if you need to talk about the wave nature. So I saw a question the other day about why does emission spectrums have discrete lines? And I read the examiner's report and said, look, a lot of students talked about the wave nature of matter, but it wasn't really required. Just to say that electrons exist in discrete levels and the transitions between discrete levels means discrete amounts of energy is emitted. And that corresponds to discrete wavelengths only appearing in a spectrum. So sometimes the questions are quite simple if we just read them, and that comes with a bit of practice. But the more you can focus on that, the more chance you've got, because that's an area where students sometimes find that a little bit difficult. So the mere fact that you're watching this video and focusing on it means you're giving yourself a bit of an advantage. Tabulating information is handy. Yeah, putting it into a bit of a table. This is the last study design dot point. And again, rather than just copying it once and leaving it, see if you can spot patterns. For example, laser light and LEDs both rely on electron transitions to produce their light, whereas synchrotrons and incandescent globes rely on acceleration of charges. So that's just, tabulated information might be handy for you. And again, some standard definitions. So polarization, just on polarization, I might come back to, it's good practice to just draw polarized light. Again, rather than have it once, like cut and pasted. So this is unpolarized. This is sort of at 90 degrees. Then I'll draw one that's polarized vertically again. Just with practice, you can get good at those rather than write them once. It's better than, the more you can handwrite your notes, I think it's better than clicking and cutting and pasting. Handwrite, just gets you used to remembering them more and more. So polarization, dispersion, resonance is one. If you feel it's something that gets asked often, if you're drawing on it and you think, oh, what is that again? Or you feel you can discuss it, but you'd like to become a bit more polished, just have a bit of a short definition to use as a guideline. But the more you can practice talking about it, the better. Here's the photoelectric effect. I've noticed there's about 3 key pieces of evidence that the photoelectric effect addressed. The fact that there's no time delay for photo emission, that there's a threshold frequency which exists. So if I was to try and talk conversationally about that, we might say that the wave model says that any old frequency should emit if you have enough time, because energy can accumulate continuously under a wave model. But that's not what was observed, that there was a threshold frequency, and that photo emission occurred without virtually any time delay. And that the particle model did explain that, because energy is delivered in a photon or a particle, and that all the energy could be transferred at once. All right, and that a wave model didn't explain it, because if for very dim sources, time is required. So there's some general thoughts on the how to use the A3 sheet. I'm interested to hear any comments you might have, how you use the A3 sheet. And if you've found any of this useful, I'd be interested to know. Thank you very much for watching the video, and all the very best with your preparation. Thank you for watching another physics coaching video.